All right, so we're going to do some review of operations on rational expressions, which remember, rational expressions are just really fractions, but we're going to put some algebra into them as well. So we're really just going back and remembering how do we do our operations on fractions. Okay, so we're going to start off taking a look at this particular sheet, and I'm going to just do some select problems off here. I'm not going to go through every problem because there's a lot of repetition, and I want to make sure that you just have a good overview of all of the different types of problems that you might see. Okay, so we're going to actually start off with problem number 2, okay, which deals with dividing fractions. Okay, so we need to take a look at this problem and remember, how do we divide fractions? Which, if you remember, what we're really trying to do is multiply by the reciprocal, which means we're going to flip over the second fraction, right, and then proceed like we normally would with multiplication. So if I'm looking at this problem, okay, I'm going to start off and I'm going to go through term by term and I'm going to try to factor. So I'm going to look at 2x minus 3 and say that doesn't factor. I'm just going to bring it down. 5x plus 1 also does not factor, so I'm just going to bring it down. Okay, so now I would like this to be a multiplication problem. So when I factor the numerator here, okay, it's actually going to show up in the denominator of my multiplication problem. So if you go through and do all the factoring methods that you know, again, you can kind of do your AC factoring on this, and the answer that's going to show up if you were to do your AC factoring correctly, you should get a 2x minus 3, okay, and a 3x minus 2. Okay, so if you take a look at this, we can confirm that this is correct because I have a negative 9x in the middle and a negative 4x, okay, coming from the 2 and the negative 2. So this is the correct set of factoring, and you can just do a quick check and confirm after you've kind of off to the side done your factoring work. Okay, I can do the same thing with my denominator here. The denominator in the division problem will become the numerator of my multiplication problem because I'm flipping this over. So again, you get factors of 5x plus 1, okay, and 3x, okay, minus 2. Okay, so if you take a look again, I can double check. This is negative 10x plus 3x. There's that negative 7, so I'm good with that. Right, and then what we said was once everything's factored and I can see all of the parts of these polynomials, we're going to try to cancel one thing in the numerator with one thing in the denominator. And this is actually a very unique problem here because watch what happens. I have a 3x minus 2 and a 3x minus 2. I have a 5x plus 1 in the denominator and a 5x plus 1 in the numerator. I have a 2x minus 3 and a 2x minus 3. Everything canceled, and this became 1, and this became 1, and my answer is 1. Right? So this is actually a case where I divided and everything went away. And that could potentially happen, right? So we went through the process correctly. We flipped over the second fraction. We factored. We canceled. Everything's gone. My answer is 1. Okay, so let's take a look at a multiplication problem. So, let's go back to our division problem real quick. We have to state domain restrictions. Okay, so in this case, domain restrictions would be anything that makes the denominator of the fractions anywhere throughout the entire problem turn into 0. So where can x, what is x not allowed to be? So if I'm taking a look at all these denominators that I just canceled, I'm going to say this 5x plus 1, if I were to set this equal to 0, okay, and solve it, I would find out that x is not allowed to be equal to negative 1/5. If I were to set this 2x minus 3 equals 0, I would find that 3/2 is bad. And if I were to check this 3x minus 2, I would find out that 2/3 is bad, right? So we actually get 3 different values that we have to restrict because they would make the denominators turn into 0. And remember, with division, we also have to take a look at the numerator of the second problem, the second fraction, because that was a denominator when we started. But in this case, 5x plus 1 we already took care of, and 3x minus 2 we already took care of. Okay, so don't forget to state your domain restrictions. We can't just say the answer is 1. We have to let people know that there were some bad values to avoid. Okay, so in our second problem, same concept. I just actually have to factor more. So this x cubed minus 9x, I have 2 steps of factoring, which I'll show you off to the side. I'm going to first GCF that x away. Okay, and then I'm going to look at this and say that is now a difference of 2 squareds. That's x squared and 3 squared. So I'm going to turn this into x plus 3, and x minus 3. Okay, and so that's my new numerator. So I'm going to go through and every single problem, this is now x plus 3, and x minus 3. And the rest of these are just what multiplies to the end and adds to the middle. So in this case, we get x plus 3 and x plus 8. Okay. On my numerator on the second fraction, remember, I'm not going to flip this one because it's multiplication. We only flip for division, right? So I'm going to say in this case that the numerator here is going to stay the numerator, and it's going to become x plus 8 and x minus 1. And in my denominator, which again is going to stay where it is, I get x minus 3 and x minus 1. Okay, so if I do my canceling now, I'm going to look and I see an x plus 3 and an x plus 3. I have an x minus 3 and an x minus 3. I have an x minus 1 and an x minus 1. And I have an x plus 8 and an x plus 8. The only thing that's left here is x. So I'm going to say my answer is x. And that's it. Everything else went away. Again, domain restrictions. I have a negative 3 that's bad. I have a negative 8 that's bad. I have a positive 3 and a positive 1. So there's actually 4 values. X is my solution, but x is not allowed to be equal to negative 3. Okay, and I'm going to actually write this as plus or minus 3 because I have a positive 3 and a negative 3. Okay, it's not allowed to be equal to negative 8, and it's not allowed to be equal to positive 1. Okay, so multiplication and division, factor everything, cancel as much as you can cancel. So let's take a look at another division problem, but I'm claiming that this one is, it looks a little different, but it's not really. Okay, so my next problem here, problem 4, this looks a little bit more intimidating, right? We're looking at fractions inside of fractions, but what I want to remind you is that this fraction bar, okay, really just means to divide, right? I'm saying take whatever's in the numerator, divide it by whatever's in the denominator, right? So I'm going to rewrite this expression and say this is x squared minus 16 over x minus 3. That's the numerator. And it is divided by x plus 4 over x squared minus 9. Right? And now I can just proceed like we did in problem number 1. So my first fraction, remember, is going to stay the same. I'm not going to flip that one. X plus 4 and x minus 4. Okay? My denominator is going to be x minus 3. That doesn't factor. X squared minus 9 is going to be my new numerator, but I'm going to factor that into an x plus 3 and an x minus 3. Okay? And the numerator of my original problem becomes the denominator after I take the reciprocal. Let's do some canceling, x plus 4 and x plus 4, and I see an x minus 3 and an x minus 3. So x minus 4 and x plus 3 that are in the numerator had no common factors in the denominator, so I'm going to leave those exactly the way they are and just say my answer is x minus 4, x plus 3. I ended up with a 1 in the denominator. I don't need to write over 1, so I'm not going to do anything. And again, it's entirely okay, remember, to leave your answer in a factored form. You don't have to FOIL this out and tell me that it's x squared minus x minus 12. That's correct. It's not wrong to do that, but it's not necessary to do that, right? Where it's entirely, it would be an extra step of work that wouldn't make your answer any more correct, okay? So again, we have to be careful now. So we're going to look at this and say, here are my domain restrictions. I'm not allowed to have 3, okay? So x is not allowed to be equal to 3, okay? X is not allowed to be equal to negative 4, right? Those are the easy ones, okay? And here's the catch. This x squared minus 9 used to be a denominator. Before we flipped it, it was a denominator. So I actually am going to say in this case that the x plus 3 that came from x squared minus 9 is also going to give us a bad value. So I have to say in this case the negative 3 is going to be bad as well, because if I plugged in a negative 3 right here, it's going to say in this case 1 over 0, and I can't divide by a fraction that has a 0 in it, so that we have to take that one out as well. So you got to be really careful when you're dealing with division that you make sure that anything that's left over in the second fraction has to be restricted as well. So be careful with those problems, just a little nuance, but nothing you can't handle. Okay, so let's talk about adding and subtracting. So with adding and subtracting, it's a little bit different. We are not allowed to have, we cannot add or subtract unless we have a common denominator. So if I'm looking at these two fractions right now, x squared minus 4 and 3x plus 6, they don't have a common denominator. I can't combine them at all. So in order to figure out what the common denominator is, I'm going to factor all of my denominators, and I'm going to try to figure out what they have in common and what they don't have in common. We're going to do a comparison of the denominators. Right? So I'm going to go through and I'm going to say x minus 2 on the numerator. Let's leave it alone. The denominator in this case becomes x plus 2 and x minus 2. Okay. And then I'm going to do the same thing with the second fraction. I'm going to say this is 2. And this has a GCF of 3 in it, which is 3 times x minus 2. Alright, so if I'm looking at this, it looks like they both have an x minus 2 in them, so that's not anything that I need to worry about. But I'm seeing that the first one has an x plus 2 in it, and the second one doesn't have an x plus 2 in it. Right? So I'm actually going to start by changing the second fraction, because it needs an x plus 2 to match the first one. So I'm going to put an x plus 2 here. Okay? And that means that if I'm changing the denominator, I need to change the numerator as well. Okay. And then I'm going to come back here to the first one and say, let's compare again. This one looks like it has an x plus 2 and an x minus 2. And when I look over here, now this one does as well. But this one's got this additional 3. Right? So I need to make sure that the 3 shows up in the first one. So it's actually going to be 3 multiplied by the numerator and the denominator. So now when I simplify this, I'm going to say this is 3x minus 6. I am multiplying this out. Okay? The denominator I'm going to leave alone. I have a GCF, x plus 2 and x minus 2. And then I'm going to do the same thing with the second one. Distribute 2x plus 4. Okay? And the bottom is still 3, x plus 2, and x minus 2. Okay? So now, if I look at my denominators, they match each other, and I can add them together. So I'm going to just combine terms in the numerator and say this is 3x plus 2x. Well, that's 5x. Negative 6 plus 4 is negative 2, and it is over my common denominator, which again, feel free to leave factored. We don't need to actually multiply all this out. And I'm going to say this is my final answer. Okay? So just a couple little notes about this one. The first thing you might have noticed is when I did my factoring up here, I had an x minus 2 and an x minus 2, and I could have potentially canceled those. The reason that I didn't cancel those was because if I canceled out the x minus 2 here, I would have looked at this one and said, well, it's got an x minus 2 in it, and I would have had to reintroduce the x minus 2 again. So when I looked at it, I didn't do the canceling because it had to be there, because it had to match the second fraction, which had an x minus 2 in it. Right? So you may have noticed that just I didn't cancel it because it had to be there later on in the problem. Okay? So again, we should state domain restrictions. In this case, just 2 and negative 2 look like our bad values. Right? I'm not allowed to have a 2 or a negative 2. They will cause the denominator to turn into 0, and that would be bad. We're not going to do that. Okay, so similar concept for problem number 9. I'm adding together 3 fractions in this case. Right? So I'm going to go through this one, and I'm going to say, before I start comparing, again, I want to factor this third denominator, and in this case it factors into, conveniently, x minus 4 and x minus 2. Right? So I'm going to look at the 3 of these and make sure they all match each other. Right? So I'm going to start off with the first one and say, it has an x minus 2, okay? But when I look at the one right next to it, the one right next to it has an x minus 4, so I need to make sure an x minus 4 shows up in my first denominator, okay? And then I'm going to look at the third one and say x minus 4 and x minus 2. I have both of those. I'm good. I don't need to add anything additional. So my original numerator of x plus 1 is now also going to be multiplied by that x minus 4. And so I'm going to do the same thing with the second one. It already has the x minus 4, right, and the x plus 2 in the top. Okay, it needs to have that x minus 2 so that it matches the other 2 fractions, which means I need an x minus 2 up here. And fortunately for us, the third denominator was x minus 4 and x minus 2, so I don't need to change that one at all. Okay, x minus 4 and x minus 2. Right, so I'm going to leave this one as 16 minus 5x. Okay, so now I can say I have a common denominator. That means that I can add the numerators together. The problem is that I can't add together things that are unsimplified, right? So x plus 1 times x minus 4 I need to combine. So I'm going to go to this and say that x plus 1 times x minus 4 turns into x squared minus 3x minus 4 over my denominator. Okay? So it gets a little repetitive. You have to keep repeating the denominator, but we have to do it. Okay? The second one turns into x squared minus 4. Again, that's the difference of 2 squares. Right? And I'm going to keep using the same denominator, x minus 2, x minus 4. So I just flip this one over, which is okay. We're allowed to do that with multiplication. And again, I didn't change the last one, so that I'm just going to repeat. Okay? And it's over x minus 2, x minus 4. Okay? So we're finally ready to combine. Okay? And this is going to look like, let's go through. I see x squared plus no x squareds in this one, so that's 2x squared. Negative 3x plus, there aren't any x to the firsts, plus negative 5x. So it's really negative 3x plus negative 5x. Well, that's negative 8x. Okay, and then negative 4 plus negative 4. Well, that's negative 8. Negative 8 plus 8 is positive 8. I'm sorry, negative 8 plus 16 is positive 8. Right, and so I'm going to say this is over x minus 2, okay, and x minus 4. So I just added together. I did combining like terms in the numerator, and I ended up with this expression. Okay? But we are not done. Okay? Here's why we are not done. this numerator looks like something I can factor, and we always leave our answers to fractions in simplest radical form. So I'm not going to stop here because it's possible, and I just have to check if it's going to actually work, that something's going to cancel when I factor this numerator, this brand new thing that we just made. So in this case, this factors into 2. Okay, and again, if you pull out the 2, you end up with 2 times x squared minus 4x plus 4, right? So I'm looking at this thing and I'm saying, oh wait, does that factor some more? In this case, it does. It factors into x minus 2 and x minus 2. Right? So I actually have to factor this again. Okay? This is equals, okay? And it's over x minus 2, x minus 4, okay? And now when I compare the numerator and the denominator, there's something in common, so I got to cancel. I'm going to get rid of one of these x minus 2's with the one in the denominator. So my final answer in simplest form is 2 x minus 2 over x minus 4. And this is my final answer. Again, a couple of domain restrictions. X is not allowed to be equal to 2 or 4. Right? But again, once we got to that last step, and we were finally able to add together our fractions because we had common denominators, we ended up with a numerator that factored nicely, and we were able to simplify our expression a little more. So you should simplify, be careful about that when you're going through the problems.